Hello and welcome to my video, lesson 3.4, combining transformations. So we've been looking at all the different types of transformations so far we've been looking at all the different versions of transformations. So reflections, stretches, translations, and we've looked at this general form of the equation, and we've noticed how these different letters, the A, the B, both of those ones have to do with the stretch and have to do with the reflections. Okay, and then what we did was we also looked at the H and the K value. And it's important to notice that the H is a negative H and the K is a plus H. So that negative or minus H there makes a difference because you're going to have to multiply by -1 in order to find the actual H value in many of our equations. So let's take a look at mapping notation now, written down as a general way, and then we'll look at some example questions. So we're combining multiple different transformations at once. So having a reflection and a stretch, having a stretch and a translation. And one of the rules is that we normally, unless you're told otherwise, stretch and reflect, those two can happen at the same time, but do that first before you do a translation. So a translation happens second. So translation happens second. So that is good to know as a general rule, unless you're told specifically otherwise, because that is why we have it the way we have it written here. So the stretch happens first, hence with bed mass, right, or order of operations. We know that division and multiplication come before addition and subtraction. So when we do the B and the A next to, unless we specifically have our brackets done differently, this is how we do it, in which case those happen before the H, which that's not written as an H, the H and the K values. So the H here and the K value, those happen second. Okay, so let's take a look at some different types of questions that you might see from this topic. So this first one, we have the parent function of square root x, and it says a bunch of different transformations. I have them written in different colors so that we can do them one at a time and show what is happening one step at a time. And that's really what you have to remember, is this might take a little bit to get used to. Once you get used to it, you might be able to do multiple steps all at once, but as it is, just start one at a time. So to start with, our parent function is I'm going to make that a little bit thicker, is the function y equals square root x. So 1, 1, 4, 2, 9, 3, 16, 4, and that's probably all we're going to need. 16, 4 isn't even going to fit here for our first function, but we can certainly work with what we have. So it'll look something like this. All right, so this is our square root x function and our parent function. So now let's take a look at the first step, which is to reflect it across the y-axis. So when we do that, we can look at the table of values and what changes. Well, if it's reflecting across the y-axis, reflecting across this kind of mirror, you could say, then every point, just however far it was, it now just becomes a negative version of itself. So the x values are changing. So all the y values stay the same, 0, 1, 2, 3, 4, but now our x values become negative versions. Whoops, negative. There you go. So we end up looking like this. And it'll look something like that. All right, so one at a time. We just do this one at a time very carefully. Let's take a look at the next one. We're going to do this one in green. So stretching vertically by a factor of 2. Again, you can do this. You can look at like the data table and look at what I'm doing there. You can look at the graph and look at what I'm doing there. It doesn't really matter how you do this. You can even use mapping notation for this to do it all at once. And I'll show you one point as an example for that later on. But right now, we'll just look at doing it this way. So stretching vertically, that means our y values are changing. So we're going to keep our x values the same. So anyways, vertically by a factor of 2. So we're going to multiply by 2. 0 times 0 is still 0. 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4. 6 times 2 is 3 times 2 is 6. 4 times 2 is 8. So now what we can do is still the same point, but now basically we're just doubling every point here. So it's going to look like this, roughly. All right, and then our second to last one is our purple, which we have looking like this. So it's translating to the right by 6. So we're going to add 6 to every y value. So our x value, which means our y values stay the same. So add 6, add 6, add 6. Whoops. Oh yeah, that's right. Add 6, add 6, add 6. All right, so yeah, pretty good actually. I did pick far enough. So our first point will be negative 10 and then 8. So this is the highest point. Negative 3 and then 6. Positive 2 and 4. Positive 5 and 2. 6 and 0. So this is going to be our new curve. It's going to look something like that. It looks the same as the green one, except you kind of just have to ignore everything till about here. So if you just look at that part that that's showing that I haven't scribbled over, that part is just the green one that's shifted over to the right by 6 everywhere. Okay, and then our last translation is down by 2. So now our x values stay the same, and you go down by 2. And hopefully you can see what I'm doing. So every point, I'm just going down by 2. Every point, down by 2, down by 2. See, now I'm just looking at the points. You could do this however you want. You could have looked at the points on here and gone to the right by 6. It doesn't matter. You can pick however you want, but I just went down by 2. Or you can look at your points based off of what you've written. So it's going to look like this, roughly. I think my intersection between the green and the red line should be a little bit further up. They will intersect, but a little bit further up. But I think you guys can see step by step how I got here. So the red line is our final answer. Okay, so this is pretty fun. Hopefully you all feel that way. It's super fun. What about trying mapping notation? So if we use these values, can we find the values of B, H, A, and K? So let's just see here. If it reflects across the y-axis, that is an x value that's changing, so b is negative 1. Okay? If it stretches vertically by a factor of 2, a is 2. If it translates to the right by 6, h is 6. If it translates down by 2, then k is 2. We can also choose alternatively, instead of doing it this data table way or by looking at the dots on the graph, you could simply put whatever into mapping notation. So what that could look like is, let's see if I can. No, I can't. That's okay. What we can do is put it into mapping notation. So we would put all of our values in and then put our original values. So which point do we want to do? Let's pick this point. We can pick any point we want, but let's pick that one. So 4 over negative 1 plus h, which is 6, comma, and then we have 2 times 2, yep, plus 2. So let's see if this works out for us. This will give us negative 4 plus 6, so this would be 2. Lots of 2's in this question. 4 plus 2, so this would be 6. So that means our third point down should be 2, 6. Let's see. Oh, hold on. Did I do something wrong? Oh, yes, I did do something wrong. Oh my goodness. All 2's. There you go. So what I did wrong was, because it said down by 2, that should have been a negative 2 over there. So anyways, so by doing 4 minus 2 instead of 4 plus 2, it's now 2, 2. And you can see how that would be the same as our third point. So you went straight from the original straight to the transformed point. So if you're only doing 1 or 2 points, that might be the way to go. If you're doing a whole graph with a lot of points, you might want to pick a more visual graphical method, or perhaps doing it by data table. So either one of those methods works great. Let's take a look at 2 other questions. So this is our next one. Describe the transformations necessary to go from the parent function above to the transformed function below. So what we're going to do here is basically pull out the a value, the b value, the h value, and the k value, right? Because those are the ones that tell us the different transformations. Now, the a value is very easy. It's just 2. The b value is where it's a little bit tricky. You have to recognize that the negative will come out, and you actually have to go like this and square that. So the whole function kind of changes a little bit by taking this negative outside of the brackets, because if you remember, by looking at our original general form, the b is outside of the brackets. Still in the function, replacing x, but it's outside the brackets here. And so that's why we have to make sure it's outside the brackets. Okay, not because the value of b really changes, but because the value of h changes to remember again, you have to flip it. So it changes to a positive 5 instead of being a negative 5. So it kind of flips and then flips back to positive. Looking at the k value, it is negative 3. So now we have all of those different things. Now we can describe, this is the key here, describe the transformations. So what we're going to do is have a vertical, did I do the same basic? I kind of did, didn't I? Vertical stretch by factor of 2. We have a horizontal reflection because of the negative 1. So you could say in the y-axis, to be more specific. Then we also have the, yeah, I really did make it very similar. Translation, maybe I'll just say to the right by 5, and down by 3. So the only difference here is that it's to the right by 5 instead of right by 6, and down by 3 instead of down by 2. So look at that, I made it very, very similar. Okay, last one for this video. Looking specifically at mapping notation, I know we did one example. Let's take a look and do another. So using mapping notation, we can go and change the domain and range of a function directly without having to actually draw anything, without having to look at the graphs. Really, if you know the original domain and range, which we do in this case, and we know the transformations that are occurring, which we do again in this case, all we have to do is make sure we pull out the A value, the B value, the H value, and the K value. And then once you have those, you can plug them in and basically calculate every point, every one of these 4 points. So let's do that right now. The A value is -1 from right here. The B value is 1/2, but we have to take it out actually to be a little bit more careful. So we're going to have to take out that 1/2. And so what that means is we're going to have to actually go to a 6 here, plus 6. So hopefully you can see why if we take out the half, we have to multiply by 2 here and 2 here to cancel out by the x, but to keep it all evened out. Okay, so where are we? So the B value is 1/2, the H value is 6, and the K value is also 6. So plugging that into our mapping notation here, what we're going to do is just basically, try it out per part. So let's do it with -4 first. So -4 over B, B is 1/2, and then plus K, oh right, that should be plus H. I have that written down wrong because I copied and pasted what I had up at the top there. So anyways, plus H, which is 6, which I guess in this case H and K don't matter. A value is -1, and so it's negative, and then whatever the Y value is, so that's the -6. So we're looking for the minimum point in both directions. And then we have the plus K, which is the 6. Okay, so all of this to go to -8 plus 6, and then 6 plus 6. Okay, and that can go to -2 and 12. Is that right? Yes. So the new domain will have a minimum of -2, and the range will have a minimum of 12. We might actually have to check about that because, again, there's a reflection happening. So just be aware, if there's a reflection, something might flip. But for now, let's put it in there, and we'll see what happens. Let's take a look at the other 2 points, doing the exact same process, but now these 2 points. So we have 8 over 1/2 plus 6, and we have minus, and then 5 plus 6, and we get to 16 plus 6 minus 5 plus 6. So this is 22 and 1. So this is 22 here and 1. So you'll notice here We do have the max and min, but because of the vertical reflection, right? The vertical, i.e. the range, has flipped. So it's actually going to be 1 to 12. So it's actually been flipped. So notice that this has been flipped. Maybe I'll use black. All right. So I hope this video helps you guys understand combining transformations, especially with the graphing and with the mapping notation and describing transformations. Good luck, everyone.